Good morning, Tejasvi. Good morning, all of you. Let's wait for a few minutes. Yes, good morning, Sainath. Any doubt from your side, beta? Good morning, Swati, beta. Yeah, good morning, Hanok. I have discussed almost all the important cases. We have discussed in very detail by taking different type of examples, all the exceptions, right? So, am I audible to all of you? Please quickly respond. Am I audible to all of you? Yes, yes. Okay, thanks. Yeah, good morning, Santosh. Good morning, Shri. Good morning, Sumant. Yeah, okay, fine. Fine. So, I hope you must have done this question. Okay. Yeah, I am good, beta. How about you? In this question, if you solve, this is the last question I have given for homework. Actually, to solve such kind of questions, there might be, you can see there are two you can find two species. One is cation, other is anion. You must be aware about cation and anion, right? So try to identify in such kind of questions that there can be two or more than two group of atoms, okay, which are forming different type of anion or cation. This is anion which is forming nitrate ion, and this is ammonium, right? Now you can solve it. In this case, if you solve it, there are 4 hydrogen, so nitrogen will get -4 because hydrogen is less electronegative. -4 and +1, so in this case nitrogen is -3, and in this case nitrate it is +5. This is how you are going to solve it. In this case also, ammonium, this is ammonium, so you need to have a skill to identify that it is having an ammonium ion, and this is NO2 minus. So if you try, this is -3 and this is +3. Is that okay with everyone? Please quickly respond. You will find such kind of questions. Okay, great. Okay, so what so I am giving some questions to you guys, right? So it's a basically a quick test. Okay, the purpose is just to have a quick revision, right? So I will give some questions, find out the oxidation number of the underlined element. These are 5. Then I am asking for oxide bond. Yeah, good morning, Vani, good morning, Deepak. Right, so these are question, and it is carrying 1 mark. It is of also 1 mark. This is of 2 mark. Again 2. This is 1. So this 7, and this is of 3 marks. The last one. So you guys are having 8 minutes, right? You guys are having 8 minutes. You solve them, then I will discuss the each of them. Yes, Sai Darshak, good morning. After a long time, I am seeing you. So quickly solve it. Beta, you do not need to Shashank beta. Shashank beta. You might be right or wrong. I do not know. Just solve all of them. Shashank, solve all of them and write on your notebook. This is test. So you are not expected to write on chat. I will give you the answer. Then I will ask you uh, how many of these you have solved it correctly, right? Solved. You are having only 6 minutes. So who have joined late, you need to solve this, right? And just I will give you answer, then you can self correct it. Yes, Ji Suman, tell me. Tell me, beta. Okay, fine. You're having 3 more minutes. Yeah, good morning, Mansa. Ji Sumant, what are you doing, beta? Yes, yes, yes. We are now the last minute. Last minute. Yes. Okay, so we are done. The time is over. Okay, 30-second more. Okay, guys. So in this case, whenever you see such kind of combination in which there is some metal and non-metal, okay, you can write like this. In this case, barium belongs to alkali, so it will be having plus to alkaline earth metal, and this will become S2PO2. So this is crisscross method, so it will become minus. And if you solve, then Sasank was right. It will the phosphorus oxidation number for phosphorus will become minus, sorry, plus one. Right. So this is the correct answer. Plus one is the correct answer for phosphorus. In Ki3, it is fixed that K is plus and I3 is minus beta. So in this case, if you see, then it will become minus 1 by 3. For now, you understand that it is minus 1 by 3. NoCl4. So NO, I have already told you NO is different kind of. It is NO plus, and this is ClO4 minus. So chlorine is having, chlorine will be having, it is having, chlorine is having plus 7, and nitrogen is having plus 3. Right. Ammonium, this one we have already solved. This ammonium plus, and this is sulfate. So in ammonium, nitrogen is having, already we have discussed, plus minus 3. In sulfate, sulfur will be having plus 6. CS3SO. CS3SO is nothing but like this. CH3, this is also CH3. So if you solve for this using electronegativity, you will find that the oxidation number of sulfur is 0. It is 0, right? So these were the answer for first question. And in case of second, you need to just find out in which case oxidation number is coming greater than maximum oxidation number. This is, I have given you one trick. If oxidation number calculated is coming greater than maximum possible oxidation number. So maximum possible oxidation number for sulfur, maximum oxidation number for sulfur, it is +6. For chromium, chromium also it is maximum oxidation number for chromium, it is also again 6. For chromium is also 6, and for this is for sulfur and this is for chromium. Both of them can have maximum oxidation number +6. So you must be aware of the maximum and minimum rule. That is very important. You need to know maximum and minimum rule. It will help you. So in this case, if you see H2SO4 is having only +6, so this will not show. This will show carrot acid. This is carrot acid. This will also show. This is Marshall's acid. This is Marshall's. This is known as oleum. This will not show. This will show. This will also show chromium peroxide, right? So these 4 will show. So who have marked all 4, they can award them. So each for each, it is +3/4. If you have correct one, then you can add 3/4 marks, right? So these 4, if you have corrected all of them, if you are making something wrong, then -1/4 for this question. So for this question, you can add your marks. You can add your marks, right? You can add your marks, and please make the record of this test, right? In your notes, you can keep somewhere, right? So anyone who have got 10 out of 10? Anyone? You can send me the screenshot or the photocopy or any scan of your notebook to me on Telegram, right? +3/4 for each correct answer. If you have corrected all 4, then you will get 3 marks. If you have corrected only 3, then 9/4. Only 2, then 6/4. Right? Any doubt? Sai Darshak or Mansa, Sumant, any doubt, beta? Please tell me if you are having any doubt. Otherwise, we will move to our next topic. No. Sorry. Yes, Chatur Teja, any doubt, beta? First, we explain again, sir. First one, beta. This one. This can be solved by using zigzag rule. We know now that we can crisscross method. So Ba plus 2, Pa and H2PO2. There are 2 things. So this 2 will move. Actually, this 2 is coming from where? It is coming from here. And here 1 is coming from here. Crisscross method. Now you can solve it. Hydrogen will be having, for hydrogen it will be having 2 into +1. Phosphorus we do not know. Oxygen 2 into -2. Total charge is -1. So if you solve, X will come as +1. Mansa? Anything else? Anything else? Sir, 5. 5(1) is beta. You need to understand this sulfur is attached to carbon, which is less electronegative. So it will get from here, from these 2 carbon, it will get -2. From oxygen, it will get +2. If you add them, then it will become 0. Right? Yeah, I will explain. Okay, fifth one. Yeah, okay, fine. For third one, it is NO. I have already told you it is nitrosonium salt. Sorry, nitrosonium cation. right? So in case of nitrosodium, sodium, the charge is on nitrogen, that is +1. So +1 charge is there. So if you break this 2, and nitrogen is more electronegative, so you will have -2 over here. -2 and +1, already there is +1. So it will become, sorry, -2 I am writing, +2. Oxygen is more electronegative, so it will get +2, and if you add, it will become +3. And in this case, it is very simple. Chlorine X plus 4 into -2 should be equal to -1. So this is how it will become 7. Santosh? Do you get it? Yeah, fine. Okay, fine. So anything else? Anything else? You can solve again. These are some good examples, right? Simple one or good examples. So you can solve after the class also, right? Let's move to our next topic, beta. Oxidation and reduction. We have already studied oxidation and reduction. So I will quickly tell you oxidation and reduction. The old concept, oxidation is nothing but the old concept is nothing. It is first, I have already told you in the first class itself of this topic, addition of oxygen or any electronegative atom. Second is removal of hydrogen or any electropositive element. Generally metals are electropositive and non-metals are electronegative. This is just we are developing our understanding. Metals are electropositive, all metals are electropositive elements, and not non-metals, generally non-metals are electronegative. They are more electronegative, right? This is old, we have already studied. The new concept, loss of electron. If in any process loss of electron takes place, then we will consider it as oxidation. Very important. We will use it in electrochemistry. In electrochemistry, we will use this. So loss of electron. For example, if some it is given and it forms A plus X and X electron. So this will be termed as loss. Loss means it will come in the product side. So this with this reaction, this is half, and this will be oxidation half reaction. This will be termed as oxidation half reaction. Why it is half? Because it is having electrons. Generally, if you see any complete reaction, you will never counter any complete reaction which is having electrons. So if somewhere electrons are present, then that we term it as half. Yeah, I have told it in first class, I think, right? Then second one is increase in oxidation number. Increase in oxidation number. This is important. Okay, this is very good. This you should know, right? Increase in oxidation number. If you see for any compound, if any of the element is undergoing with the increase in oxidation number, then you can say that substance is getting oxidized, right? If oxidation number is increasing, for example, CO plus O2 gives CO2, right? Let us balance it, 2 and 2. So in this case, if you see, here it is only +2, here it is +4. So you can see oxidation number of carbon is increasing. So you can say carbon is getting oxidized. Oxidized. It's very simple. Carbon is getting oxidized. You can use this rule also, that oxygen is added, right? So you can see carbon is getting oxidized. This is oxidation beta. You should remember this thing. then if oxidation number is increasing, it is known as oxidation. Is that okay? Is it okay? Okay, fine. Fine. That's very simple, and you will utilize this. You will utilize this in many cases better, right? This is very trivial and but very important concept, right? You should know. Yes, and on the similar lines, we can easily define what is reduction, right? We can easily define what is reduction. Reduction. So our old concept is nothing but removal of oxygen or any electronegative element, right? Second is removal of gain of hydrogen or any gain of hydrogen or any electropositive element. But we need to focus over here. This was old story, beta. This was old story. We used it in 9th and 10th. Right? The new one is gain of electron. If you see any process in which gain is taking place, so you will term it as, let's say there is B and it is accepting Y electron and getting converted into minus Y. Right? So this will be known as reduction half cell or reduction half reaction. Half reaction. As it also involves electrons, that is why it is half. Now, the very important one is decrease in oxidation number. Decrease in oxidation number. So let's say I am taking this example. If you are hitting it, it will become SO2 plus half O2. So in this case, if you want to solve, it will become plus 6 and here it is getting plus 4. So we can say oxidation number of sulfur is decreasing for sulfur. So reduction of sulfur. In this process, reduction of sulfur is taking place. Now just focus. I will tell you some very good things. Logic wala things, common sense. If you have understood it, then tell me. Understood. Fine. Okay. It is clear. Now just tell me if there is a compound. Okay. If there is a compound, right? There is a compound, and I ask you in H2S. Oh, okay. I am just asking through a question. If 1 mole of H2S, please mute yourself, beta. No, beta Jagdish. No, Goli Pranay. This is bad habit, beta. Bad habit. Don't do such things, beta. Please remove it. If 1 mole of H2S, if 1 mole of H2S if 1 mole of H2S is losing 8 electrons, what is the final oxidation number of sulfur? This is the question. Okay, so now focus over here. If such question is given, so you need to understand there are only two elements, there are only two atoms. One is hydrogen, which is present in +1, and sulfur, which is present in -2. H plus, if you see, it is having 0 electrons, right? It is not having any electron, right? Because it was having 1 electron which already has been taken. So now it cannot lose any electrons. For sure, sulfur is the other atom which can lose, because it is in its minimum oxidation state. So after losing, its oxidation state will increase. So if you see, it is not capable of losing any electron. So this is very important thing which you need to understand, which you need to apply your logic, right? Because hydrogen cannot lose any electron, and this compound is losing electrons. So obviously this should be coming from sulfur. They should be come from they must be coming from sulfur, right? So this is the simple concept which you need to apply, right? Is that clear, beta? So if sulfur is losing electron s -2, now it's losing electrons, so it is giving 8 minus electron. This is how you need to write the equation. Now what is the charge over here? What will be the charge over sulfur? So that for a balanced reaction, charge must be balanced. Please mute yourself.
Please mute yourself.
Now give me the answer, beta. So beta, in this case, it is only 2 electron. It's a charge of 2 electron. It is 8 electron, right? If you want to equate them, right? So it should be here +6 charge. So it should be +6. It should be +6. If it has lost 8 electron, then it should be +6. Then only if you see the difference, it will come as 8. This reaction is clear with everyone or not? Please tell me, because it is very important. And this charge from the initial classes, I am telling, this is not 2 coulomb, this is not 6 coulomb. It is charge of 2 electron. This is also charge of loss +6 electron, right? Is it clear with everyone? So it's a very good question, just to understand, to have good conceptual understanding. Yeah, okay. Anyone else who is having any doubt? I will repeat it again. So out of 2, right? And there is another thing I have already told you, that alkaline earth metal, they will not show variable oxidation state. Alkali metal will show +1, alkaline earth metal will show +2, right? Also p block can show, yes, Cytherun, p block can show, okay, they can show multiple oxidation state, as well as d block elements. If there is any d block element, then in any reaction there is very high chance that it will be showing multiple oxidation states. So it is the characteristic of, it is the property of d block elements that they show. No beta, just this, don't do such thing. Okay, so I am asking, in acidic medium, KMnO4 gain 5 electrons. Calculate oxidation number of manganese. So it is saying like this: KMnO4 is taking 5 electrons. Now there can be doubt. KMnO4, it is gaining, that is why I have written it on the reactant side. K plus, it's a metal, it will not gain until unless someone else is not present, and you see other atoms cannot gain. Okay, you give priority to other atoms because K, it is +1 oxidation number is shown by K, right? That is fixed. Mn is present in +7. Oxygen is present in -2, so it cannot gain. It cannot gain, right? It does not have a space. It is already in minimum oxidation state. It is minimum oxidation number. Oxygen is present in minimum, so it cannot further gain. It has already achieved its lowest oxidation number. Already in lowest oxidation number, so it is not possible for oxygen to gain. Now you are remain with K plus and Mn plus. So alkali metal or alkaline earth metal will not gain electron in the presence of other metals or other which are able to gain electrons. So this will also not so. This will also not gain. This will gain. So Mn plus 7 will gain 5 electron. So here if you see, it is in 7. If it gains 5 electron, it has to become Mn plus 2. Is it okay, beta? Is it okay? Tell me. These are very important and very conceptual things. Quickly tell me, is it okay or I repeat it again? What about others, beta? Shriya, okay, okay. Quickly respond, beta. That is very important. Repeat. Okay, fine, beta. You need to see, but with the time you will be able to solve it. You will have no doubt. KMnO4 is very good oxidizing agent. We will see later. KMnO4, there are only two things which can accept electron, either K plus or Mn plus. Okay, but these are very rare. They will not accept electron. They will accept electron when there is no other option, right? It can also gain electron, but it is given that 1 mole. Let me say here 1 mole of KMnO4. So it can, maximum of it can accept 1 electron only. It can go in K. It cannot go in K minus. So it is given 5 electron. So 5 electron can be gained by this. Okay, this cannot itself alone gain 5 electrons, right? So K plus, alkali metals will show +1, alkaline earth metal will show +2. So considering that, also I have told you that D block elements show variable oxidation state. So if you are seeing D block element, so try to change the oxidation number of D block element. This is the thumb rule, that if you find some D block element, so try to change it. Okay, fine beta. So I think that is very clear. Okay, if it gives such kind of questions, right? So that's okay. You will be able to solve it, right? Okay. Now moving to oxidizing agent and reducing agent. Very important concept. Oxidizing agent. These are specific reagents which oxidizes others, and you know what is the meaning of oxidizes others. Oxidizes others means, we have already learned few minutes before, earlier, that oxidation means they increase oxidation number, or they add oxygen, or they remove hydrogen, right? Or they remove electron from other. These were all 4 things for oxidation. So if they oxidizes other, though it means they add oxidation to other element, or removal of hydrogen take place, or they take electrons, or they increase oxidation number of others. They are agent always works for other. Agents always work for other. Okay, agents always work for other, right? Agents, ticketing agent, if you see ticketing agent, they try to make tickets of others, right? Traveling agent, they try to book the flights or anything for others, right? So they are specific reagent which oxidizes others, okay, also known as, they are also known as oxidant, okay. If they are oxidizing others, then their reduction takes place, okay. If they are trying to oxidize others, so their reduction takes place itself, they are getting reduced, itself they are getting reduced, they are getting reduced. That is, oxidation number of oxidizing agent is decreasing, okay. Similarly, on the similar lines, if you want to write reducing agent, reducing agent, so they are specific reagent which reduces others, reduces others. It means they are also known as reductant. Itself they are getting oxidized, they are itself getting oxidized. That is, oxidation number of reducing agent is increasing. Yeah beta, that is right, that is right. So I'll give you the, I'll provide you the list, I'll provide you the list, okay. I'll provide you the list, okay. You need to identify which of them is, because this is something which you will use in organic chemistry, organic, physical, inorganic. This is something which will come again and again, okay. So they will try to oxidize other, they will supply oxygen to others, they will take electrons from others, oxidizing agent. Then opposite will be done by reducing agent. How to identify, how to determine or determination of oxidizing agent? This is very important, because you are very new, but with the time you will learn some. You will, if you see compound, you will identify that yes, this is oxidizing agent. First thing is compound having element in its maximum oxidation state, its maximum oxidation state, oxidation number maximum होना चाहिए बेटा. If there is something present, at least one element should be in maximum oxidation number. If you want to do the same exercise for this, how to determine reducing agent, how to determine reducing agent, then in that case compound must be having or having, you can write compound having element in its lowest oxidation number, lowest should be there. So you must be aware about lowest and maximum, okay. Then second, all the metals are very nice, are reducing agent, okay, because metals are electropositive and they try to remove or they try to lose the electrons. If they are losing electron, so they will be providing electron to someone else. They are trying to reduce others. So all metals being electropositive, they are being electropositive. They are electropositive, so they try to remove the electron. This is the property of metals, right? Like sodium, potassium, rubidium, manganese, calcium, aluminium. If you see any metal, then they are always, they behave as reducing agent. Now the next, all the metal hydrides, all the metal hydrides, metal hydrides, metal hydrides like NaH, KH, MgH2, like this. They behave as metal hydride. Metal hydride. In this case, metal oxides behave as oxidizing agent. Is that okay? Any doubt? Is that okay? Any doubt from your side, beta? Clear. Okay, fine. So I am making some list. You must be aware of some good oxidizing agent and reducing agent, like KMNO4, K2Cr2O7, PbO2, CrO2Cl2, yes, HNO3. So or this NO2O or something, some other oxide. So these all will, in if you see in this case, Mn is in +7, so it is its maximum oxidation number. Okay, just a second. I am again sharing my screen. Please do not do such activities, beta. It disturbs the class. It's a request from you guys. Okay. Otherwise, I will write your names and ask to management, or I will tell to your submit to your parents. Right. So if you see Mn is in maximum oxidation state, that is +7. So it will behave as oxidizing agent. K2Cr2 +6, it will also behave as oxidizing agent. PbO2 +4, it belongs to carbon family, and this is the maximum oxidation number can be shown by carbon family. So it will also behave as oxidizing agent. CrO2Cl2, here chromium is in +6, again oxidizing agent. +5 nitrogen, it will also behave as oxidizing. That is why we need to have good understanding of oxidation number, because we are required to identify which of the given reagent is behaving as oxidizing agent, right, or reducing agent. So for that, you might be required to calculate oxidation number. If you want to write some good reducing, H2S, right? This is H2S, or all metals I have already written, or the HCl, HBr, HI, all these hydra acids. These are hydra acids. Hydrogen, and they behave as acids. These all will behave as reducing agent. Right? This is also reducing agent. If you see in any reaction, they will try to decrease the oxidation number of others. This is also reducing agent. Right? H2S, this thing. Is that okay, beta? I will share the list of some important oxidizing and reducing agent, right? Yes. So this just to give the idea. But there is something else. If compound is having the spelling of compound is not right, please correct it, is having element in its intermediate state, its intermediate state, it can act as both reducing agent as well oxidizing agent. So these are some very good things which I am telling you. For example, O3, okay, this O3 H2O2 H2O2 SO2 CrO2, right? In this case H2O2 it is in -1, neither maximum nor non-minimum. SO2 +4, as sulfur is not maximum nor minimum. Chromium +4, nor maximum nor minimum. In oxygen also, in ozone also, we will study the structure. Some of them are present in -2 and some in +1 or something. So it is also in we will see 0. 0 will be its average oxidation number. But if you see by go by structure, then there are elements, there are atoms present with different oxidation number. So these are some good examples. You must know at least these two. These, or I can write so many. HClO2. Okay, anything which is present in HNO2, right? So these all will behave as, they can act as, sometimes they can act as, sometimes they will not. So these are some known, very known examples, these, right? Also, I want to tell you one very important thing. If you see S3PO4, H2SO4, H2CO3, right? They do not act as oxidizing agent. If you see here, it is in +4. Carbon is in its maximum oxidation state. Phosphorus is it's in maximum, but they do not act as oxidizing agent. Do not act as oxidizing agent. You will not see them acting as oxidizing agent. If you find in some reaction, HNO3, then there is very high possibility that it will act as oxidizing agent. Oxidizing agent means it will try to increase the oxidation number of other elements, but they will not do such thing. However, they are present in its maximum oxidation state. And if we are talking about H2SO4, if it is in dilute state, then also it will not behave as oxidizing agent. But if it is in concentrated, sometimes it can act as mild oxidizing agent. So we will study all of this in inorganic chemistry. But before coming to inorganic, I am just giving some introduction, right? So will you be able to identify which of them will act as oxidizing agent or which will not act as oxidizing agent? Tell me. Please quickly respond. Yes, sir, clear. So I've already told you this thing, right? So this is some very important things and important concepts, right? Now moving to next thing, redox reaction. What is redox reaction? Redox reaction. So I want you to revise, please do revise maximum and minimum oxidation number rule or concept, right? I have given in the initial in the first or second class. So you try to identify the maximum and minimum of each and every element. Okay. So redox reaction, in this case, any reaction you can define, any reaction or any chemical reaction can be defined as like this. Any chemical reaction can be classified into two. One is redox, another is non-redox. You can define any reaction, any chemical reaction in these two, redox and non-redox. So in redox reaction, you will see oxidation number of at least one element will be changing. At least one element is changing, right? You will see that oxidation number is changing. No element will be undergoing change in oxidation number. Undergoing in change of oxidation number, right? Okay, so example of this thing is the first one, nitrogen and hydrogen, they are adding to give twice of ammonia, right? This is the favorite. So in this case, if you see, nitrogen is 0, now it is in -3, hydrogen is 0, now it is in +1. So you see here its reduction hua hai iska, it is undergone reduction, and this is undergone oxidation, right? So at least one, more than one can also happen. But for non-redox reaction, if you see NaOH, I am taking example of NaOH and HCl reaction, it will form NaCl and H2O. Now if you check, it is here +1, it is also +1. Everything, oxidation number of each and every one is same throughout the process. So such kind of reaction are considered as non-redox reaction. In redox reaction, oxidation of at least one element must change, right? Okay, so redox reactions are nothing but, redox is made up of two words. Redox is made up of two words: reduction plus oxidation. So in the same reaction, reduction as well as oxidation is taking place, right? So chemical reaction in which oxidation as well reduction is taking place simultaneously. Again, I am telling you, oxidation means simply it means increase in oxidation number, and reduction it means beta decrease in oxidation number, right? So you can see if there is any reaction in which oxidation and reduction both are taking place, then that will be termed as redox reaction. If you see PCl5, in this case also PCl3 plus Cl2, you see here phosphorus is +5, chlorine is -1. Now phosphorus is +3 and here chlorine is 0. So in this case, chlorine is getting oxidized, its oxidation number is increasing. Chlorine is oxidized, which chlorine. But if you see phosphorus, it is getting, phosphorus is getting reduced, phosphorus getting reduced, phosphorus reduced. This is how we classify redox and non-redox, right? Is that okay, beta? Please tell me, quickly respond. Is that okay? So it's a request to all of you, please join class before 10. I request all of you to join class by 9:55 AM, right? Because it will save our lot of time and you can also ask the doubt, right? So I request all of you to be present at 9:55, right? If I can be here, why you cannot be present? Why you cannot join the Zoom class on 9:55, right? Do not delay the class. The time is very precious. Okay, if in every class you are taking 10 minutes, so that's a loss of huge time, 10% of time, right? 10, or sorry, 10, I am saying it's 16%, right? So try to be present before the class and you can also ask the doubt. Okay, so link was sent 2 minutes late, sir. Yeah, today it has happened, but I'll ask them to send you the link as quickly as possible, right? Okay, okay guys, so I wanted to explain one more topic, that is disproportionation. Very important, disproportionation reaction. But as time is not allowing, so in the next class we will understand disproportionation. So please go through these things, try to identify, try to Google what is oxidation, oxidizing agent, what are different type of reducing agent, right? Try to Google them. Oxidizing agent, reducing agent, right? What is redox reaction? Try to understand all these things. Or you can also read the NCRT, redox reaction NCRT, right? So in the next class we will understand disproportionation, and if time allows, then we will understand basic of balancing of redox reaction. So in the next class we will understand at least two things: disproportionation and also balancing of redox reaction. So try to present on the time, try to be present on the time, right? These are two very important things: balancing and disproportionation. Okay beta, thank you so much. So I am just finishing the class. Thank you guys. Yeah, I will send the notes. Yeah, bye beta.